So hello, can you introduce yourself to our students?
Hello, I'm Anuradha Reddy. I am a researcher. At the moment, I'm an independent researcher, and I have a background in the field of interaction design and engineering and new media. So I'm quite an interdisciplinary mix, I would say. And I have been practicing design for a while now, and kind of have a specialized interest in craft approaches to computation. So when I say craft, I mean working with yarn and yeah, different kinds of art forms, pretty much. Yeah.
And I'm curious what brought you to that?
Mm. I
What,
think
yeah.
um, so. So I do have a very, as I said, a mixed background. And a lot of the times I tend to get pushed into fields that have that become really hard to kind of understand any of the complexities, like they don't have anything tangible to attach themselves to. So here I'm talking about like when I was in engineering, it was all about the formulae, or if it was in computation or computer science, it's always like programming, which is, I mean, as material as it is, it still didn't kind of stick with me. I needed something to do with my hands all the time in order to make sense of the world and to make sense of complex ideas or concepts. And kind of that's where I come from. Yeah.
Hmm. So I like to ask this question. How do you define AI art, or what does AI art mean for you?
Hmm. That's a that's a bit of a difficult question, partly because of the times we are in, where everyone's an AI artist for some reason, which is also kind of interesting. Then who am I to? I mean, I think AI art, and right now anybody can have a definition for it. So, I mean, in my own view, I find it difficult to say what is AI art, as much as I could say that um, it is more like AI generated, but art is always subjective. Art is always part of a social context. So to call something AI art requires kind of some kind of agreement between us to say what is AI art.
Mm.
And I'm not sure I have that agreement with with my circles, or yeah, it's currently under debate. And it's yeah, it's both problematic for very yeah, for obvious reasons, that AI is a technology that is very hyped, and we don't know exactly how it will develop, and we don't have any accountability for it. So yeah, I mean, and the art part is the exciting part. That's why I'm here for it.
Uh-huh.
And that's what I'm here to explore and find out together with you and yeah, everyone else who's interested. Yeah.
Well, cool. Well, thank you for being here. I wondered if you might want to talk about some of your projects or a particular project. Maybe introduce that project, and then we can talk about your workflow and what drew you to this project or what excited you about the project. But yeah, do you want to?
Yeah.
Is there anything you want to share?
Yeah, sure. I can share my screen
Okay.
and go through some of the recent projects I've done. Um, let's see. It's this one. All right. I think you should be able to see my screen now.
Yes.
Okay. So this is my portfolio, where I have a list of projects that you can scroll on the right. And I'm not going to go through all of them, but then the most recent project I've done is an Islamic geometry-based period tracking and moon phase calendar. Apologies for the long title, but this is sort of an example of how I work. I take something like computational, like as like data, and try to correlate it to computational patterns and geometries, and using materials like hardware materials and so on. So that's kind of an example of my work. But in relation to AI, I have done some recent projects. So for example, you should be able to see this recent article I wrote about how I intervened into my craft curiosities, and I use DALL-E, an OpenAI service, in order to kind of interrogate both the craft and AI together. So in this particular example, I opened DALL-E and I wanted to ask DALL-E to explain what cross stitch is to me. So then I started giving DALL-E some prompts. I started asking DALL-E, okay, show me what one single unit of cross stitch looks like. And it kind of went crazy. And then I had to obviously kind of tweak the prompt until I kind of arrived at something that was similar to what I wanted. So I wanted DALL-E to kind of show me what, the basic, on a very basic level, what does cross stitch look like? So
can I interject quickly for students who are unfamiliar with cross stitch? Can you just give a brief explanation of what you mean by that?
Okay, yeah, I'm sorry.
No, that's fine.
Cross stitch, yeah. Cross stitch is a form of embroidery. It's an embroidery art skill, I guess I would say. And it's basically made using regular kind of, you can use cotton threads, you can use kind of like linen kind of threads, but it's made over a gridded textile structure. So everything is kind of, it's in grids, so it makes it easy for you to, for example, do counted embroideries. So you can, for example, if you want to make a square, you can count exactly how many kind of pixels are in the square, and then you can start stitching them. So that's kind of what cross stitch is. And the way you do it is by crossing your stitch. So you go from the left to the right, and you keep going, and then you go back and you cross the stitch. So then you form each pixel that way. So this is, yeah.
And it's a lot of this with embroidery and weaving. We've been talking about looms and programming and being able to plan the design ahead of time, and these older computer systems, and I mean old in the sense of like 1860s, Ada Lovelace, stuff like that, were designed in order to sort of automate this process, not of the design itself, which was still being done by people, but the stitching these patterns into fabrics, and not necessarily cross-stitching, but the fundamental principle of sort of plotting and using these sort of measurements, equal measurements, in order to make an image in your textile, and then being able to program that is really at the core of computation and arguably AI. It's about planning ahead, figuring things out mathematically, and then enacting them, in this case, into physical objects and physical design. So I just wanted to highlight that connection to some of the readings that my students have been doing. So thanks for that brief pause.
Yeah, I mean, it's extremely, it's relevant to the history of computation with like as we just said, with looms and Charles Babbage and the invention of, the algorithm and, I mean, I should say Ada Lovelace, not Babbage, but anyway, either or both. And I think this is an interesting kind of, I mean, I think it's interesting that we work with images here, whereas like looms and these kind of technical computing devices, they work based on some kind of like form, like an algebraic formula, or like, it does some calculations. And here we are talking about something on the level of images, on what we see and what computers see. So it's kind of a vision based approach. And here I was curious how DALL-E or AI understands what cross stitch is. So when I after several prompts and tweak variations, I landed with this kind of these sets of let's call it cross-stitch units. And then I tried to kind of recreate it on paper, just because you can see in this image how, these cross-stitch units are not really like well defined, even though you can kind of tell that they're like sort of like little pixels, right?
Mm.
And I recreated them on paper on a grid chart. And when I drew them together, I got this feeling like, they're like a family portrait, when the one you would have, in a house with like grandparents and great grandparents, you can see the family traits. And I started referring to these kind of set of cross-stitch units as family resemblances.
Mm-hmm.
And then it occurred to me that, oh, wait a minute, I didn't come up with this term. It's actually Wittgenstein who said who came up with the term. And then I went back and I read a little bit of like, the context behind family resemblances. What did he mean by that? And then, and it turns out that it turns out that there's an interesting question here. Like, can we then, like, if Wittgenstein's idea of family resemblances applies to DALL-E, let's say it does, and let's say that, that we are, okay, maybe I should first explain what family resemblances
Thank
are.
you. Yes, I was going to ask.
Yes. Okay. So, I do write a little bit here, so I'll just read this out. So, family resemblances entail the cultural concepts we ascribe to things that are thought to be grouped into a category that do not always have one defining feature, but a series of overlapping features. So he gives the example of games. And when I say he, I mean Wittgenstein. Wittgenstein, he gives the example of games, where he says games can be many types of games. There's games for sports, there's board games, there's like other kinds of, you can have like, computer games. And these are all games, even though they all differ based on certain kinds of features or traits, or like they might have like certain rules. Some might just be for play without any rules. And yet we still understand like culturally what, like if I tell you this is a game, you will understand that it's a game. So cross stitch is similar in that sense, that even though there's like an overall understanding of cross stitch, there's many different types of cross stitch, and it varies according to different cultures and histories. And there's different kinds of cross stitch that you can do based on the materials. Like sometimes if you use either cloth, you'll end up with a certain kind of cross stitch. You can do cross stitch as a part of needlepoint, which ends up looking a little bit different. And all of this encompasses cross stitch, right? And I was wondering if DALL-E was kind of, did DALL-E understand what cross stitch is then? Is DALL-E able to like, bring this complexity that's about the term cross stitch to me in an interesting way? And what I realized very quickly was that obviously that it gives you, the more you ask it for variations, it does not give you variations of necessarily the whole bundle of what cross stitch means, but it gives you variations of individual images, right? So which looks something like this. And then I was thinking,
just to contextualize a bit again, and sorry, sorry to interrupt, but when we're talking about DALL-E 2, and this was just me clarifying for students who haven't gone into that interface yet, that DALL-E 2, on top of this option of typing a text and having an image created, it also allows you to upload an image and make variations. So this is what you kind of are talking about when you're talking about the variations, is it's possible to take an image and then have this system say, well, here are some things that look like that. And it's doing that in ways that we will talk about in more detail in class. But this idea of the family resemblance is a really interesting one, because it's this kind of riding the variations and the various permutations. And some artists get fanciful and they say, oh, it's like parallel universes, or these kinds of things. So it's interesting just to keep that note in mind. I'm just highlighting that. So thank you.
Yeah. And so what occurred to me was like, okay, how do I then, if this is what DALL-E calls cross stitch, then how do I read these images? Then is there a way for me to understand where do these images come from? What kind of cross stitch is this among among the varied meanings and understandings of cross stitch, right? So then I just was curious, and I started looking on the internet if there was any kind of way to read cross stitch images. Then I looked for keywords like I combined keywords like cross stitch and encryption, cross stitch and encoding, and then I found these kind of interesting historical references to a cross stitch style called pisanki, and it's a Ukrainian or a Slavic style of embroidery. And here what they do is they take a Cyrillic alphabet and they create stylized versions of it in cross-stitch format. And they use a lot of interesting computational principles. For example, they work with symmetries, they work with, reflective symmetries, they work with rotational symmetries. And this is kind of interesting because on the one hand, like it made me curious. Okay, so does DALL-E actually understand some of these computational formats, or, can I decode it in a way to see maybe if there was any kind of, kind of language kind of game going on between DALL-E and Pisanki, the embroidery format. And then
But
I
to be
tried.
clear, these are you refer to them as computational, but these predate what we would call computers.
Yes.
Yeah.
Yes, definitely. So everything that I talk about as computational, I think the most of them predate. Yeah. Yeah. I mean, I just wanted to like refer to them as computational because I think that for me that gives me a hook to understand and talk about, make my work, or make it an interesting way to approach my work.
Mm-hmm.
Yeah. And so yeah, I did try to solve some puzzles there, and I made a small reference here in the article to one of my master students at the university when I was doing a postdoc there, and she played with computational grammars of a different set of symbols. And these are called Slavic light symbols. And then she also used a puzzle kind of format to get people to engage with these kind of craft languages that existed like pre-computation. So yeah, so then when I went to YouTube, I tried to pick up Cyrillic phonetics. I tried to understand how can I decode some of these, these cross-stitch units that DALL-E gave us. And then find out what they could mean. And then I found interesting kind of like just little alphabets put together. So I was wondering, could they be someone's like initials? Are they, something that's embroidered on like a handkerchief, or maybe someone put that on a little artifact in their home, and that was the image that DALL-E picked up. And it didn't make a lot of sense because obviously it could be someone's name. It may just be gibberish, but most likely like it's gibberish.
And I like that a lot, because so much of what our engagement with these tools is actually us making sense of things that don't have a sense, right? As you're kind of getting to, but you may see an image that is kind of confusing, or you're not sure what it means, or the text, if you use text generation, it might tell a story that doesn't make sense, but we're still asking, well, how could it make sense? What could it mean? And then finding those meanings ourselves. And that's part of that relationship that we are in when we're making with these tools. So I think that's a great illustration of that too.
Thank you. Yeah, and then I mean, I didn't want like the project to end right there, because I mean, I think this is an extremely beautiful and historical artifact, like art form, and I wanted to learn some new ways of expressing myself through it. And that's kind of where I also want to kind of pull back the questions about like what AI art could mean if you perhaps reappropriate it for your own purposes. And here I cross-stitched my name. So I shortened my name from Anuradha to Anu, and then created a pattern on the grid format, and then recreated that and cross-stitch on a denim shirt, on a denim blouse. And then also 3D printed a coaster that I have with me right here. So yeah, these are kind of computationally like, informed generated artifacts. And I think they have this hybridity, which I find really fascinating. And I feel like embracing some of these kind of cultural crafted art forms can bring an interesting kind of return to, and questions about what AI can do, and what extent can we have some kind of cultural say about what these systems should be doing from a critical perspective, as opposed to the way it currently is. Yeah, which is not working for most of us. Yeah. And I think I'll just end that project there. Yeah.
So yeah, it's great. It's I really love what you say about the images coming and doing something with those images. A lot of the AI art conversation that we hear is, here are some images I made with AI, and that's fun and fine and good, and some of them are very beautiful and some of them are very creative. People get creative with their prompts. But at the same time, the idea that these images are a material is a really interesting one. Something that you could take and use. And I wonder if you want to kind of go into that a little bit more.
Yeah. Yeah, I think these are interesting. So when we generate like images, I think it's important to understand how these images come from data, which becomes a kind of a material to work with, rather than thinking about the images as the kind of the end goal or the outcome. Right. And I think that's kind of the way we need to be thinking about these systems as well. So for example, I can show you another project briefly.
Yeah, please.
Let's see. Yeah, so for example, I made this this towel, this crocheted towel. Yeah. And I call it the Internet of Towels, because I just wanted to take a piss out of the term IoT. And it's a lenticular towel. So when you see it from straight up on the top, it doesn't look like anything, but when you tilt it to a 45-degree angle, it shows a QR code. So it becomes an image that can be read by a computer. Right? It's not readable by humans, but it's readable by a computer. And I wanted to play around with that a little bit. And lenticular images, again, they existed pre-computation, I think. Yes. And you've seen these kind of images. You find them on postcards, you have them on children's toys. But these images are really powerful. They're used by the military in certain cases, and they have a lot of application more than toys. And these can become interesting materials from a computer vision point of view, if you with the materiality of it, looking at it not just as a flat image, but working with the three-dimensionality of the material and understanding the computer as such as well. And I just
sorry, just to emphasize that point, there's an interesting limit to much of how computers see, and one of the big problems is how does the information that comes into a computer get depth? Because information that comes into a computer is essentially like two-dimensional, right? It's using a camera. It's cameras, or I should say, this human idea of vision, where we can see and we can sort of determine that something is like, a few feet away from us or very close to us, is actually a very complex problem for computation. And that's worth highlighting as we're talking about this, that computers see in very different ways from what we see, and solving that has been a major issue in computer vision. So that's really I just wanted to emphasize that point because it's an interesting one. So that shifting, as you do with that lenticular object, is really curious, because even though it's laying sideways, and we might see that as, okay, this is on an angle, the computer sees it as flat. It sees everything as flat.
Exactly. Yeah. Yeah, and I think I wanted to also in this article, I also like emphasize a little bit how QR codes are also playing a big role. They're really ubiquitous now. All of us use QR codes for a lot of things. So I was also trying to make a point of that, how computers see and how we see, and we can't read QR codes, but computers can, and so on. And I wanted to combine the two techniques, and this is where I talk about like how I wanted to work around this with crochet. Also making a point about like going back to the history of like looms and like how yarn is computational, it's hardware, it's like with every stitch that you make, you can actually compute certain things, right? So I started off with like, yeah, small experiments. Like I started with a data matrix instead of a giant QR code, and started working around, okay, how many, like how precise do I need to be in my yarn stitching in order for a computer to recognize it. And that was a very difficult process, because it had to work not just with the flatness of the thing, but also the height of the, as you can see here, you can see different heights of the fluting, right? And then eventually, yes, I managed to get a QR code towel working, and that took a long time, and it was a lot of effort, but I learned a lot from it. And then I also ran, even though I don't talk about it here, or do I? Oh yeah, I do two things here. So the first thing I did was I made it a little piece of code in block-based programming. This is from the software called the Culturally Situated Design Tool, CSDT, which is led by a research project by Professor Ron Eglash, who works with this idea of, let's see the right term, yeah, justice oriented design, basically. And it's taking culturally important artifacts and creating computational libraries around them. And so this particular yarn library is called the Yarn Art Library. So it allows you to create yarn objects in computation. And I recreated my QR code towel so that anybody can come in with their QR code and then put it into the software, and they get the pattern that they can stitch into a towel. And the second thing I did, which is not here in this article, is that I also ran it through a machine learning algorithm, a computer vision algorithm to see to what extent can a computer accurately determine, like at what angle, for example, can it actually tell that it's a QR code or not. So is it able to hide in the wild, let's say? Yeah, and that was about like, so the accuracy, I don't want to call it accuracy at all, because it was not accurate, but it was about 70-80% that it could hide in the wild. Yeah. So this is another kind of project where I use my materiality to investigate, how computers read, how computers see the world, and how we can kind of play with in the in-betweens, let's say. Yeah. Yeah, and I mean, I also have time to talk about another project if you want, but I don't know. Do we have time?
Sure, let's talk about one more.
Okay. So this is a project I made, I think it was a year ago, maybe. Yeah. And this project is one where I made home security, a smart home security device using crochet. Yeah. Okay. So this is basically what I was talking about previously, that with every stitch that you make, you can actually create a computationally unique artifact, right? So this time I played with the materiality of a variegated yarn. When I say variegated, I mean a yarn that's multicolored. So the yarn that has different colors on it. So when you make the same artifact, and here as you can see here, I made keys. like little amigurumi toy, plush toy keys. And each of these keys are individual, uniquely identifiable objects because no two keys will ever look alike. So I use this to train a machine learning system. So I used an existing. So here I provide a little tutorial for making the key if you wish to ever try. And then I trained a machine learning open source like a tool, an online tool called Teachable Machine. And here you could basically train the computer to learn what each of these keys look like. And then I wanted it to be a local private thing. So then I ported the whole machine learning model into a Raspberry Pi, and I created a small smart home security system. It's not foolproof. I mean, you can definitely, get away with maybe showing taking a printed picture of the key. But I mean, so I did try and kind of queer it a little bit more, but I wasn't that successful. I tried to also get the computer at some point using the stereoscopic vision, like your stereoscopic camera, to understand if the computer can differentiate between different kind of crochet stitches or not. And I wasn't able to get that far, but yeah, this is another project.
So one of the things that I find really interesting, just thinking about this and thinking about the work that you are showing and thinking about this history of weaving and data and computation, there's it's very easy for us to say, and we've done it even in this conversation, that like, oh, these are sort of looms and old computers, right? And we think about like punch cards or whatever. But one of the things that's really interesting to me is when we start getting into DALL-E 2 and the images that it produces, or GANs, or any of these types of image making tools, that really the images that we're seeing are tapestries, in the sense that this machine is still thinking about pixels, it's still thinking about data in the same way that you are, right? With each of those dots on the graph paper that you're making, you're saying, I want a color here, I want this color here. The machine is still doing that. That is still how AI image is being generated. It is still saying, right, the pixels are smaller, but that's what it's doing. It's saying this goes here, and if this is here, then maybe this one should be next. And it's this process of saying, what do I want to do now that I put this stitch in? What's the next stitch? And the computer is kind of doing that. And that's kind of at its heart what an AI generated image is a stitching together of patterns. It's just a question of, now these patterns are not coming from looms. They're not coming from you saying, make this pattern. It's saying, I want to see something that looks like this pattern. And then it's producing something and giving you these options. And of course, it does this so fast that we almost forget that there's a process, right? It's like this completely automated thing now from start to finish. So I wonder, one of the things I'm curious about as you're making these projects is every stitch, I think, is an opportunity for reflection on that relationship and that process. And I wonder if you've kind of investigated that, just in terms of your own thinking about every stitch and planning things. Do you think there's a relationship? Do you ever think about yourself or the work you're making in relationship to that kind of process?
Not really, no, because I think I do, like when I make these kind of objects, I do it also for the joy of it, for the calm that it gives me. And I don't always want to reflect.
Yeah.
That
makes sense.
Yeah.
Yeah, because and this is an interesting thing too, which is where does the art come in, right? A lot of the art that we make is, and that humans make, is because they enjoy making art. They enjoy the process. They enjoy the creativity. People like to go out and take pictures, right? People like to illustrate drawings and think about what they want to make. They don't necessarily think, okay, I've drawn a line. Now, what is the next line I'm going to make, right? What's the most computationally accurate based on previous images that I have seen? Where should this line go? So thank you for for not just saying yes to my proposal, because it suggests something else deeper, I think, about what the creative process is when we talk about creativity in machines and creativity in people.
Yeah, I mean, I would like to say though that there's a lot of back and forth, like, you know, like I try and create something with a computer, and then I work for some time by myself with you know, yarn, and then I take it back to a computer. So that way there's a lot of back and forth. But I wouldn't say it's during, yeah, as much. Yeah.
Yeah, and so you're seeing, it comes back to this, I think, not to put words in your mouth, but it comes back to this idea of the process, creating materials that you engage with and you work with. So it's not just handing you a finished image and saying, here's the art. It's saying, here's something, and you saying, okay, what might I do with that?
Yeah, exactly.
We've got a couple minutes. Thank you so much for everything. This is really great. I just wondered, is there any sort of issues in the AI or AI art space that have really got you thinking, or get you questioning or critical, or just feeling any kind of response to? And if you want to share some of your thoughts on what's going on in the space right now.
Yeah, I mean, I think there's a lot going on in this space, and I've really tried really hard to I wouldn't say that hard, but yeah, I tried a little bit to understand what this is. I tried to join workshops. I tried to, you know, like learn a little bit about what's Midjourney, and experimented a little bit. But at this point, I feel like there's not, I mean, there's a lot of, yeah, there's a lot of excitement and energy about what this AI art can do, and not enough ways to actually make sense of all of it. Like, you know, we are really falling behind because there's just a, you know, it's kind of imbalanced. The amount of, you know, the amount of humanity we are applying to it is quite less, I think. But at the same time, I think it's also about the, yeah, I mean, here I'm also referring to the chat GPT, GTP. Yeah, like those parts where I think we need to be more careful in terms of like how we are, to what extent are we, I mean, I've used chat GPT, I've used DALI, but to what extent does it cause real harm? And those kind of questions are still not, I mean, there's obviously, I mean, there's some great researchers, including Eric Yu, who are, you know, trying to, you know, bring those questions forward. But I think maybe we need to get better at understanding what this whole field is. Yeah.
Well, I'm always happy to end on being complimented as a great researcher. So thanks so much. And yeah, thank you so much. I'm gonna go ahead and stop the recording. But thanks again.
Thanks, everyone. Yeah.